to this computer. Okay, so what we're doing today, what I want you to do to check in with me this morning is every single person, I want you to do this. How are you feeling right now, this weather report? Let me know in the chat. Give me one word. How are you feeling this morning? I'm doing this check-in in case people are not feeling too well, or if we need space. Like, I want to make sure that I'm giving people everything that they need this morning. So please let me know in the chat if you need anything from me, how you're feeling, so that I can appropriately move through the morning, if that makes sense, guys. Okay, so you guys fill that out for me. And what does V mean? Oh, V. Okay, V, good. Okay, good. Thank you. Nice job, Nassim. It's good to have everybody. Okay, so people are a little bit tired. People are good. People are good. People are good. Okay, so guys, as we're moving through today, oh, Mr. Main. Oh, Cat Adam's happy. Yes, John is tired. I love it, John. As we're moving through today, if anything changes, please feel free to either shoot me an email, shoot anybody on team an email, even Miss O an email if you need to talk. We are here. So let me send it to you. Give me 1 second, Allison. I am here if you need to talk. Everybody is here. We are safe. We are moving forward. Okay. But if you need anything at all, please let me know. Okay. So give me about 2.2 seconds just to, I'm going to share this with Tyler. No, that was, yes, Tyler. So Tyler, if you want to check your email, I just sent you a copy of my copy. So make sure you make a copy before you start typing in it. Okay. Okay. So people are letting me know how they're doing in the chat. There are a few people. Cindy, how are you doing this morning? Let me know, please. I want to know how everybody's doing so that we can appropriately move through the day and not have any problems. Okay, here we go. So our learning targets for today, okay? Number one, I can solve, is everybody ready, by the way? Okay, so I can solve systems of equations by adding or subtracting them to eliminate a variable. So yesterday and in the previous unit, we went through and we used this idea of substitution. Substitution meaning plugging a number in and solving for the other variable and then finding that other x variable or y variable. Now we're going to be adding or subtracting them, the two systems of equations, to eliminate a variable. So now we're going to be dealing with this term or this idea called elimination. Okay. Next is I know that adding or subtracting equations in a system creates a new equation where one of the solutions to this equation is the solution to the system. Okay, so we're going to be doing this addition, adding or subtracting of a system, and it's going to create a new equation, and the solution to that new equation is going to be a solution to the system as well. It's going to make more sense when we look at an example. Okay, so if we look at this notice and wonder, I want you guys to take 2 minutes right now. Actually, I'm going to say a minute right now to just tell me one thing that you notice and one thing that you wonder. I need everybody to put a notice and a wonder. So flip back over to the slideshow, take a minute right now, and you can tell me one thing that you notice, one thing that you wonder. And I'm starting now, guys. Oh, Kyle gave me some nice ones. Thank you, Kyle. Okay, Gabe Sorali gave me some things in the chat. So did Max. Awesome, awesome. Wonderful, wonderful. We're taking another 13. Adam threw 2 things in that. Nice job, Adam. Okay. I like it. Okay. So what, oh, thank you, Abby, for throwing in some notices and wonders. Very good. Or actually a wonder. Nice job, Peyton. Ooh, Peyton told me like she did a little bit of work and she said like 2 circles equals a square. I like it. Nice. Max said that he made some notices as well. So what I'm going to have is I'm going to have a couple people unmute and tell me what they were thinking. Adam, do you mind unmuting and telling me one thing that you either noticed or wondered?
I noticed that a circle is like half the value of a square.
So circle, oh, that's not circle. C-I-R-C-L-E. It has half the value of a square. Very good. Abby, do you mind unmuting and telling me either a notice or a wonder?
I said that I wondered what each value of like the shape is. So like how much does a circle equal or how much does a square equal?
Oh, I like that. How much is each shape worth? Very cool. I like that one, Abby. That's a really good question. Wonderful, wonderful. Now, can I have Max, do you mind unmuting and telling me either a notice or a wonder that you have?
I noticed that for a lot of that that all these diagrams are equal and you can turn all of these diagrams into equations.
Okay. So he said that all of the diagrams are equal. And you can turn them into equations. Good. That's a really good thing to notice there. That was 2 really nice things. Let me just fix this spelling mistake because Miss Jermaine can spell, she promises. Wonderful, wonderful, wonderful. Everybody had such good things. Gabe said that he was wondering how many circles are equal to 1 triangle. Oh, I like that one. How many circles equal 1 triangle? That's another really good one here. If you didn't have any of these written down, try to get a couple of these notices or wonders written down. I'm going to leave it up for another 25 seconds so that you can copy these down if you don't have them, and then we're going to move forward. Thank you for everybody who put answers in the chat. I love when that happens. Wonderful. I'm going to take about 5 more seconds for people to copy down, and we will go from there. Oh, also, guys, I put up I put up the pictures of our work from yesterday. I know you guys probably saw that. Just wanted to draw attention to that in case you need to look back at that today. Okay, so here we go. Nice, nice. So we are talking about solutions to a system of equations. The solution to a system of equation is a coordinate pair. It needs to be 2 values, x, y, c, d, s, r. 2 values. Solutions always consist of 2 values. Is a coordinate pair that makes both equations in the system true. On the graph shown, the equation in a system, the graph shown of an equation in a system, the solution is the point where the graphs intersect. Okay, we know that. We've been talking about that for a couple weeks now. Okay, so now if we slip and slide down, oh, you can't hear, can you guys hear me? Is it just Gabe? You can hear me. Okay, good. Good, good, good. Thank you, Gwen, for letting me know. Okay, perfect. Thanks, Gabe. So now we're looking at 6, slide number 6. So today we're introducing a new concept, and Diego is given this system's of equations. Ooh, nice job. Kyle gave me a prediction of what he thinks is going on. So here is his work for solving the systems of equations. I want you to analyze his work. So what he did was first he did this, and then this was after he got this value of 2 for y, then he took it in and solved it for our x. But I want you to really focus in on this first sort of set of work that Diego did here. I want you to take 1 minute to, in this box, tell me what did Diego do to solve the system. I don't need a name, a fancy name. I just want you to tell me what did he do looking at this first step to solve this systems of equations. Take 1 minute right now, write your answer in the box, and then come over and let me know in the chat. When he did that, Kyle, what happened? And how did he do that though, Ian? Taking another 24. Nice, Gwen. Very good. And when he did that, Gwen, what happened? Nice. Very good. Very good. Okay. So I'm looking in the chat and I'm seeing a lot of people saying that. So Kyle said, this is what Kyle said. Kyle said he added both systems together to get a new solution, or really it's creating a new equation. So we added them together. Together. And what does that do when you add them together? What does it do to the equations, or what does it do to one piece of each of those equations? So, Sadie is here. To solve the system. Ooh, I like this answer that Gabe gave me. Gabe said that to solve the system, Diego combined like terms in the equation, right? So he combined his 3y and the 5y, and then it turned the equation. Okay, good. So when we do that, it cancels out one of our terms. Okay, so when we're adding, Tyler is back. When we are doing this, when we combine our equations like this, or when we add our two equations together, when you're doing this strategy of elimination, the goal is to cancel out one of our terms. And to cancel out one of our terms, we need to have the same value attached to that variable, but an opposite sign. So in this case here, we have a +4 and we have a -4. Do we notice that, guys? That's okay, Sadie. Okay, so what did Diego do to solve the system? He added the two equations together, and the goal of adding them together is to cancel out one of the terms so that you're left with, in this case, just your 8y. And then he divided by 8 on both sides to find my y value. And then he did exactly what we did yesterday of picking one of the equations, substituting that 2 in for the y, and finding the value of that x value. Okay, so is the pair of the x and y values that Diego found actually the solution to the system? What do we think here, my friends? I want you to take a minute to decide. Is this a y = 2 and x = 1 a solution to the systems of equations? Tell me here, and then tell me the strategy that you can use to test if you are correct. Okay, you're taking 2 minutes right now to tell me, is it a solution and the steps that you would take to test it. Nice job, Gabe. That's half of it. Show me the other half now. Nice. And then awesome job. Very good, Gabe. You need both pieces of it. Very good. Let me try to send it again. The only thing is that it's going to have the, you know what, I'll send it to you. It's fine. So I'm going to send this to you again, Tyler. So check your email again. But in your email, hit like the little refresh button. And then if it doesn't come through, send me another message. Okay. And make a copy. And let me know when you got it too, if you get it. Okay, we're taking another 34, guys. Okay, so let me know in the chat. Did you think that this solution of 1, 2 was a solution to this system? Let me know, yes or no. I got Gabe saying yes. I got Peyton saying yes. I got Max saying yes. Let's see. Kyle, what do we? Kyle's good. Abby says yes. Gwen says yes. Okay, good. So now, Gwen, can I have you unmute? And can you tell me, how can you prove, or how do you know that it is in fact a solution here?
I knew it was a solution because when I plugged in the numbers to find the answer, it came out correct.
Oh, so when we plug the X and Y in, we get them to be equal. Very good. Both equations are equal. And this idea of both is probably the most important word in this description as to why or how we know. Both of the equations, when you plug those values in, need to be true. If one is true and one is not true, that is not going to be a solution. Both of them need to be true when you plug that value in. Okay? Let me just do this real quick. Let me just okay. So, Tyler, if you wouldn't mind, you're in, make a copy, and then you can close it out, okay? Okay, so let's take a look at what we're doing for the second half of class in class right now. So, we are looking at this idea of adding equations. So when we looked at Diego, he had these two equations that sort of that had the ability to cancel each other out, right? So we had a positive and a negative, and we had those same values attached to our x's. Now, when we look on slide number 7, we're going to use this same idea of elimination, right? Getting rid of a variable and then solving to get a new variable. So if I were to look at A here, if I were to look at letter A here, is there a variable that is easily cancel outable? What do we think? And then which variable do you think it is, Ian? Oh, good. Very good. Nice job, Gwen. Sadie, very good. Yes. Gabe, very good. Gwen, very good. Max, very good. Which variable is it, Max? What do you think? Let me know in the chat. Ian, do you mind unmuting and letting me know which? So you said yes in the chat. What were you thinking, Ian, here?
I was thinking the y variable because they could cancel out easily. Because if you combine them, it would equal 0. So the variable would just not be there anymore.
Very good, right? So we have opposite operations, right? So one's positive, one's negative. That's a really important aspect of this. And they have the same value attached to like the front of it, right? So we can easily cancel this guy out. And if we add these together to cancel this out, how many x's we're adding them together? So how many x's do I have now? Nice job, Max. Nice job, Gabe. Very good, Ian. We have 3 x's. So we're adding these equations together. So we have a 2x and a regular x. So 2 plus 1 gets me a total of 3x is equal to, what are we going to get on the right side here? So 4 plus 11 is going to get me, nice job, Gwen. It's going to get me 0. Very good. Or no, not 0. What am I talking about? 15. Not a problem, Kyle Kelly. 15. So we're adding the 2 equations together in the system to cancel out one of our variables. We're left with 3x is equal to 15. And I'm actually going to bring this over to the left-hand side here just because it'll help me when I'm I'll be able to easily keep going from here. So then how am I going to get what my x value is? What am I going to do to each side? Nice job on that one, by the way, Gwen. We're going to divide by 3. Very good. We're going to divide by 3, and we're going to get an x value of going to be, nice job, Max, Gwen. It's going to get us an x value of 5. Now, I need to figure out what my y value is. Which of the equations, the first one or the second one, might be easier to plug into for this? The second one. Exactly. So Kyle, we can do the first one. You have a decision. You can make a decision. If you plug this x into either one of them, you're going to get the same value. I'm just trying to talk about which one is strategically the best one to plug it into, which one is probably the simplest to plug it into. If you're looking, it might be this guy here. So if we're looking at x plus y, we're going to say 5 minus y is going to get us equal to 11. To isolate or get that y by itself, I'm going to have to first subtract 5 from each side, right? And I'm going to be left with, ooh, okay, this is going to be tricky. A negative y is equal to 11, 10, 9, 8, 7, 6, right? So what am I going to have to do to each side to get that y to be a positive y? Because we're already at 1, but it's a negative 1. We can't keep the y at a negative 1. We need to do something to get that y to be equal to a positive 1. Nice job, Gabe. Very good, Abby. Nice job, Max. We can multiply or divide by negative 1. Both of those are going to get us to the same spot. So I'm going to divide by negative 1 just because it looks a little bit, it's a little bit easier for me to format. Divide by negative 1 and we're going to get a y value of, let me just move my box up so that I can fit everything in here. I'm going to get a y value of what? Y is equal to, very good, Sadie. Yes, Sadie. It's going to be a -6. So my final solution, if I write it as an ordered pair, would be 5, -6. Okay? So if you look at B now, B is where it's going to get a little bit tricky because we have some nice numbers here, but what do we notice? What's the one thing that's not there that needs to be there? So in this case, we had a positive y and a negative y. So before yes, very good. We can't, they're both positive, good. Ian, Gabe said we can't cancel anything out because they're both positive. So what we're gonna have to do is we're gonna have to pick one of these equations here, and we're gonna have to make it so that x is now a negative. And how do we make it so that a negative is a negative is there? There's two ways that we can do it. Okay, Gabe, that's not necessary. Yes, we can subtract, but then it'll bring my ax over to the other side, and then the equations will be in two different forms. So what we're gonna do, let me show you, is we're gonna pick one of these equations. Let's pick the second one. I don't know why. So we're gonna take this 8x plus a y, and we're gonna set it equal to the number 7. So how are we going to make this so that x is a negative? Is we're going to have to multiply the whole thing by a -1. Yes, very good. We're going to multiply this whole thing by a -1. All three terms in this equation by -1. When I distribute the -1 to the 8x, it's going to give me a -8x. Okay, when I distribute my -1 to my y, what am I going to get? Very good, Max. I'm going to get a -y. Very good. And it's going to be equal when I distribute my -1 to my right side here. What am I going to be left with on the right side of my equation? Very good, Max and Kyle. It's going to be a -7. So when you're given an equation and you're almost there, you just don't have a negative and a positive, you're going to multiply the whole thing, all three terms, by -1. Okay, so then now you're going to have this new equation, which I am going to turn blue just so that I can remember that this is the new equation. So now I have these two equations of -8x minus y is equal to -7. And I'm going to have an 8x and plus 11y. And it's going to be equal to 37. Okay, I'm going to put some spaces in here so that it's a little bit more. Okay, so now we're there. I want you to take this to the next step and do that idea of canceling out or adding the two equations together, combining them, and go through and find out what your y value is. Okay, I want you to take a minute right now, or actually I'm going to say, I'm going to give you a minute and a half right now to find that y value. So go back to your slides and find that y value. If you finish, look at that x value. I'm going to go through the steps here. Taking another minute. Nice job, Max. Nice job. Ooh, think about that sign though, because it's a -7 plus 37, Gwen. What's it gonna get you? It shouldn't be a fraction. The y shouldn't be a fraction. Okay, we're gonna take 15 more seconds and then we're gonna come back together. Okay, wonderful, wonderful. Let's come back together. Awesome. So we have this, if we look, let's jump back to the Zoom and let's take a look at what we did here. Okay, so some friends were asking me if we should keep it as a fraction or write it as a decimal. This is where we need to be really, really careful with our signs, because when we distribute this -1 to each one of these terms here, we're going to be left with 8x minus y is equal to -7. We're going to combine that with our second equation. Our x's are going to get canceled out. Okay, then we have a negative, we need to combine a -y and a 11y. So if I have 11y and I have a -y, that's like taking one away. 11 minus 1 gets us left with a 10y. Now, if you need to use a calculator for this next part, you can. A -7 plus a positive 37. Nice job. Plus a positive 37 is going to get me left with, that's like subtracting a positive 30. Then to get the y by itself, you have to divide by 10, divide by 10 on both sides, and we're left with a y is equal to 3. Now, if we would like to, we can solve for that x by plugging that y into one of our equations. Like I said, either equation is going to get you the same value. It's just about which one is going to be a little bit nicer. So I'm going to say 8x plus y, I'm going to substitute in for 3, is going to be equal to 7. And we can use this original one here because they're still equivalent. Because when we multiply by this -1, all three pieces, we're maintaining equity. So this equation right here is equivalent to this equation right here. So we can use this original equation to figure it out. We're going to isolate that x by minusing 3 on both sides. We have 8x is equal to 7 minus 3 is 4. We're going to divide by 8 on both sides. And we're going to be left with x is equal to 0.5, or you could write it as 1 divided by 2. You can write it as a decimal here because it is a terminating decimal. Okay, so the final solution here is, I'm going to write it as a coordinate pair of 0.5, comma 3. Okay. So here is the dealio. I need 1 more minute of your time. This afternoon, we are going to be doing, we're not going to be looking at slide number 8. I'm going to throw that onto tomorrow's. This afternoon, what are we doing? We are going to our classroom. Okay, and in our classroom, we have this assignment of afternoon work 1/7. Okay, let's look at the directions for this assignment here. Okay, so the directions is we have this. So what I did was I created a Loom video where I went through this application that's called Edge Elastic. Edge Elastic is a new way that we are going to be taking assessments in this class moving forward. Okay, so all of our assessments are going to be done through this program called Edge Elastic, and I put a video in here that goes through the different tools that you will need to use for this Edge Elastic website. The video is only like 5 or 6 minutes. Actually, I'm not sure. It might be 9. It's 9 minutes. But you're going to go through and you're going to work on these. They're really review type questions. You're going to try your best. If you have problems with Edge Elastic, the video is pretty self-explanatory. But if you're still having trouble, send me emails. And that is going to be, we can set up a time to talk about it. The Edge Elastic, just an FYI, is a program that we're going to be using for assessments, but we're going to be using it. Our first real big time we're going to use it is going to be next week when we have our midterm. I know. I haven't gotten the review yet. As soon as I get the review, it's going to go out to you. And we're going to have a discussion about it tomorrow. I have a meeting today where I'm going to get some information, or I'm going to make them give me some information about the midterm. We're going to have a discussion tomorrow about the midterm, and we're going to get you to where you need to be. So don't think about the midterm today. We're going to talk about it tomorrow. Just try your best with this Edge Elastic. If you have questions, send me emails, and I will see you all tomorrow, I guess. If you have questions, you can stay behind. If not, you guys can head out. It was good to see everybody today. Bye, guys. Bye.